All right, so in this video, we are going to be discussing solving equations by factoring. Um, let's start with the vocabulary portion of U substitution. So basically, U substitution is just an easier way to make a complex expression easier to solve. So it's basically the process of substituting a variable, which is typically U, in place of a more complex term or expression, so that it would be easier to solve or simplify. Okay, so let's take into consideration number one. Now remember, this topic is focused on factoring. So notice that you have x to the fourth and x squared on different sides. So what we always want to do when it's something more than a linear is to set it equal to 0 and then kind of look to see what we have. So the idea on this one is to factor, so we can look to see what they have in common. So they both have a 5x squared in common, which leaves me with an x squared minus 16, and it equals 0, right? So when I brought that 80x squared over, it now equals 0. All right, so now what we're going to do is take each term, each factor, and set it equal to 0. So 5x squared is equal to 0, and x squared minus 16 is equal to 0. Well, if we look and solve for this first term, we can see that if I were to divide by 5, I get 0, and if I were to take the square root, I get 0. So I end up getting x is equal to 0. But in this one, x squared minus 16, well, that can even be factored as, it's a difference of squares, so I could factor it as x plus 4x minus 4. And I can set each one of these guys equal to 0 and solve. So I've got x is equal to negative 4, x is equal to positive 4, and x is equal to 0. So I've got 3 answers for x. Now let's take a look at number 2. So we notice that we're supposed to factor because it's in that factoring set of notes, but it looks a little weird because it follows x to the fourth and then x squared. So this is very, very common. This is going to be what we refer to as a quadratic pattern. So when you see these, you're going to try and use U substitution. So we're going to let U equal x squared. So you always want to be able to try and get it to be that simplified exponent. And then that way, if you notice, we could take x squared squared, and that becomes x to the fourth, minus 10x squared plus 9 equals 0. And since we're letting U equal x squared, then that's like saying U squared minus 10u plus 9 equals 0. And then we can solve by factoring. So if you were to factor this, you're going to get u minus 9, u minus 1 equals 0. And they're solving, so you've got to set it equal to 0, and you've got to solve for u. And we find that u is equal to 9 and u is equal to 1. But remember, we're supposed to be solving for x. So at this point, once you solve for u, you go back and replace u with x squared. So we get x squared is equal to 9, and we get x squared is equal to 1. And if we were to take the square root of that, we would have x is equal to plus or minus 3, and x is equal to plus or minus 1. If you were to take the square root, remember you got to add that plus or minus. So in this case, we have those 4 answers. And so that's another way to tie back to a polynomial. Whatever your highest degree is, that's how many answers you should have when you solve for x. So let's take into consideration this particular problem. Again, we're supposed to be factoring. Notice that there are 4 terms, so the idea here is to look and see if there's a way to factor by grouping. And I notice that these 2 terms have x squared in common, which would leave me with x squared and then x plus 1. I notice that these 2 guys have a negative 9 in common, and that will also leave me with x plus 1. And that's the direction I want to go because I want these guys to match. So once those guys match, I can rewrite it as 1 factor, and then my leftovers are x squared minus 9. Now I can't do much with the x plus 1, so I set that equal to 0. But x squared minus 9 is a difference of squares, and I can factor that to be x plus 3 and x minus 3. So that when I break these apart, I can go x plus 3 equals 0 and x minus 3 equals 0. And now I'm just simply ready to solve. So if I were to go back over here to this first one, I subtract 1 to both sides and I get x is equal to negative 1. Here x is equal to negative 3, and here x is equal to 3. Now this is where it gets a little bit more confusing, and that's where we're going to bring in the idea of u substitution. So we're going to let u equal, and actually this needs to be a 4. So let's change that. That should be a 4. And so what we're going to do is let u equal this term right here. So x plus 2 squared. So if I have x plus 2 to the 4th power, that is like saying u squared. And that's because if u is x plus 2 squared, okay, so that means x plus 2 squared, that would be u squared. That's going to be x plus 2 to the 4th, which is what this term is. Okay, this is x plus 2 to the 4th. So now that I'm replacing x plus 2 squared with u, then I can rewrite that as u squared. And so that's how I got u squared. Plus 11u minus 12 equals 0. Now let's go ahead and factor that. So we can see that we're going to use maybe u plus 12 and then u minus 1 equals 0. So I get u plus 12 equals 0, or u minus 1 equals 0. So u in this case would equal to negative 12, and u in this case would equal 1. But remember, you're not done. We are solving for the variable x. So once you've solved for u, you need to go back and resubstitute the u. So in this case, it's going to be x plus 2 squared is equal to negative 12. And in this case over here, it's going to be x plus 2 squared is equal to 1. So now we could take the square root of both sides. We've got to add plus or minus. So I have x plus 2 is equal to, it looks like I have an imaginary answer. If I were to simplify 12, I believe that's going to be 2i rad 3. And then, of course, solving for x, I would subtract the 2. So x is equal to negative 2 plus or minus 2i rad 3. And that's 2 answers right there. Let's go back over here, take the square root. I've got x plus 2 is equal to plus or minus 1, right? Because when you take the square root, you got to add plus or minus. So I get x is equal to, let's do the work over here. So I have x plus 2 is equal to a positive 1. I also have x plus 2 is equal to negative 1. So in this case, when I subtract 2, I get x is equal to negative 1. And then over here, when I subtract 2, I get negative 3. So x is equal to negative 1, and x is also equal to negative 3. So I have a total of 4 answers, and I have a degree of originally 4, so I'm on the right track.